Hello everyone. In this video we are going to see why we are choosing our project with the help of Renesas RA62 but not with other microcontrollers. Also how we are configured DSP and how we are using the DSP features in Renesas RA62. In the previous video we had seen the demonstration of our project. This is digital twin. So first let me see what is digital twin. Basically digital twin is basically that word twin means identical of one. So basically in the previous decades we had they had used this hardware to test, so it may take cost and it uses the analog signals. So mostly analog signals are very noisy as well as it is very difficult to identify. So for that purpose we had twinned it with digital. So digital basically it requires zero cost, and with the help of digital we can able to detect the test cases if the working is correct or not. So we had chosen this prototype digital twin. Okay, now let me proceed why we are chosen this project using Renesas RA62. So basically here we had used a DSP. In our project we had used a CMSIS DSP to execute a finite impulse response filter in real time to smooth out the load cell noise. Basically the problem with the standard microcontroller is if you are running the floating point max, which is decimals, fractions, arrays on a standard 8-bit Arduino or a basic 32-bit chip like an ARM Cortex M0 Plus, the processor has to emulate the math in the software. So it takes approximately hundreds of clock cycles just to multiply two decimal numbers. So our 10 tap filter would cause the processor to stutter and freeze. So here the what is the advantage using this Renesas RA62 is here we are used ARM Cortex M33 base, which is a dedicated hardware FPU. FPU means floating point unit. And when our code in our code we have configured ARM_FIR_F32. So the Renesas routes that math to dedicated silicon that solves complex matrix multiplication in a single clock cycle, and it calculates the elevator's weight instantly without slowing down to rest of the program. So how we are configured DSP is seen now. So in the component tab we have seen that in the CMSIS there will be main, and in the followed by core M is always selected. So we had selected DSP before selecting the block. The block will be in empty. So after selecting this, you can see in the project explorer our project is elevator control. In that we go to RA. In that RA we have configured ARM. In that ARM CMSIS DSP is used. You can see the files that which we are using. These all are the files which includes DSP. So there is lot of files that related to DSP, and we are used some folders to create a FIR filter. So here are those. Then the another benefit of using RA62 was zero latency. So basically a digital twin requires concurrency, which means it will do several complex things at the exact same milliseconds right now. Also you can see in the data sheet here it is a data sheet of the Renesas RA62 which contains ARM Cortex M33. In that it consists of DSP. In that DSP we are used so scanning a physical keypad matrix and generating some random vibration noise and complex DSP max, and formatting the complex string arrays into JSON. Also using the USB cable baud rate 11520. So these are all have to take place. These are all only done by using RA62 because it has a CPU clock of 200 MHz at max, and we have utilized this. In the other microcontrollers it cannot be possible. So the problem with other microcontrollers are generating JSON string is incredibly memory intensive. So most of the microcontrollers will lead to latency and blocking. And while the chip is busy formatting the JSON string, it misses the fact that some button will stop. The advantage over is here we are using the 200 MHz crystal as we seen here. Now let me discuss about the what DSP is actually doing in our project. So basically in hardware, a lift will require a load cell. So here we are not at all, here we are using digital, so we are not using load cells. So we are generating a fake sign generation, like we are generating a fake values of load cells values. Even though there is no person in the lift, it will oscillate the values from 0 kg, 1 kg, 2 kg as you seen in the window. So this is the DSP purpose we had used here. So in practical case we have required A to D converter, also some other etc. Basically the analog signal is a continuous signal. If we are standing in the lift, then if a person enters, it will show 75 kg, or sometimes due to the vibration and EMI waves, it may show sometimes it will show 75, instead of 75 it will show like 78, 79. Also instead of 75 it also shows 68 based on the vibrations or etc. So these are very noisy signals. Let's say the total weight, actual weight of all the persons in the lift is 795 kg or 798, which is very near to the threshold. So if we are not at all converting this to a smooth end filter by using FIR, which is in the concept of DSP, if we are only providing analog signal, then there may be, due to the noise, there may be some peak overshoot of some of the cases, and it will elevate our 795 or 798 kg to greater than 800 kg. Then the lift will understand that it is a kind of alarm. Then it will tell that overload. But actually the weight is 795 only. So for that purpose, to smoothen that analog waves, we are using the DSP. So and we are using we are fakely generating the values using the C codes. Like if a person is entered, it may measure as 75. Instead of 75, it will oscillate like 78, 79, and 68, 65, etc., etc. All those values are stored in array and passed sequentially to the filter, and by using the FIR filter coefficient with the h of n equal to 0.2, 0.22 some values, it will make the noisy analog signal to a smoothened output waveform. Thus by this we are justifying that we are using the DSP from the Renesas. And the last advantage of using it is secure. So here we are configured number 9th floor as a authentication floor. If we had pressed A in the keypad matrix and followed by A+9, this will done only by using the Renesas RA6E2. Here multiple scanning also take place. In some other microcontrollers, multiple scanning may fail. So these are all the advantages of using RA6E2 over other microcontrollers. So for that advantages, we have chosen our project with this microcontroller. So in the next videos, in the upcoming videos, we can see how this UI is generated and how we had linked the East Coast Studio with this UI browser, etc. Thank you.